Hello, this video is on section 3.8, which is titled Slopes of Parallel and Perpendicular Lines. And the learning target for this is to relate slopes to parallel and perpendicular lines. So let's get started. The first one is parallel, and if you have two non-vertical lines that are parallel to each other, and that means that their slopes are actually equal to each other. So the two keywords that I want you to start connecting together are the words parallel and equal. If you have two parallel lines, the slopes are equal to each other. So now finding the slopes of two lines with given points, the slope of line L can be calculated by taking the difference of your y's, y2 minus y1, and dividing it by the difference of your x's. So our second y point is -4, and you subtract that with the other y point, which is 3. Your second x point is -1, and subtracting it with your first x point is a -3. Now figuring out the top, -4 minus 3 is -7, and the denominator, double negative turns into a positive, so that gives us a slope of 2. The slope of m is calculated using the same thing. Take the difference of your y's and divide it by the difference of your x's. -4 minus 5, dividing it by 2 minus -1. -4 minus 5 is -9, and 2 minus -1 turns into a positive with a 3 on bottom. Simplifying this fraction, 9 divided by 3 is actually equal to -3. Since these slopes are not equal to each other, these two lines are not parallel. Now if the slopes did equal to each other, if say slope L was -3 and M was -3, that would mean that we could say that they are parallel, but in this case they are not. Now if we want to look at equations of lines, like if we want to find an equation of a line that is parallel to another line, but then it goes through some different point that's not on this line, what we can do is recognize that this is in slope-intercept form, which means that it is y equals mx plus b, and our slope is -3. Okay? Now our slope is -3, and we want to find it through a point, -1, 8. An equation of a line that we could use to write these together is what's called point-slope formula. Now point-slope formula is pretty similar to slope-intercept, except you don't have to have a y-intercept in order to write the equation. You can take any slope and any point, and you can write the equation of a line. And it looks like this. Your x1 and your y1 are your points, and your m is your slope. So these are what you are going to be plugging in to your equation. These y's and x's will stay the same. They will not be replaced with anything. So we have y minus 8 from our y1 is equal to our slope times x minus a -1, which makes it a +1. And this is your equation of a line. Point-slope formula is by far the most useful, in my opinion, of an equation of a line, because you can always use it, and it's the easiest one to manipulate. Now flipping over to perpendicular lines, that if you have two non-vertical lines that are perpendicular, their product is equal to -1. So multiplying them together, they equal -1. But the words that I want you to associate with perpendicular is opposite reciprocal. Now opposite reciprocal means you change the sign, so you go from positive to a negative or negative to a positive. And reciprocal is flip the fraction. So if we take a few examples where we start out with a slope of -1/2, changing the sign makes it a positive, and flipping the fraction gets our 2 on top and 1 on bottom, and since it's a 1 on the bottom, we don't have to write the 1. These two slopes are perpendicular to each other. If you multiply them, you will get a product of -1. Now looking at another example, let's say we have a slope of 3. You change the sign to make it negative, and you flip the fraction to where 3 is on bottom and 1 is on top. These two slopes are perpendicular to each other. Now if we're looking at finding perpendicular slopes of these two lines, finding the slope of L, we take the difference of our y's and divide it by our difference of our x's. -4 minus 2 is -6, and 0 minus a -4 gives me a +4. Simplifying this fraction, we can divide both of them by 2 to get -3/2 is the slope for line L. Slope for M, 3 minus a -3, 3 minus a -3, and a 4 minus a -5. 3 minus -3 goes +6, and 4 minus a -5 gives me a +9. This fraction reduces to 2/3. So we have a slope of L which is -3/2, and then we have a slope of M which is 2/3. These in fact are perpendicular, and this symbol is an upside down T is the symbol for perpendicular. Okay, one last example where we're trying to find an equation of a line that is perpendicular to another one but through another point. Since this is written into an mx plus b form, that means that our slope is equal to 1/5, but instead of finding a parallel which is equal, we want to find perpendicular. So the new perpendicular slope that we're trying to find is opposite reciprocal, which is -5. This is the slope of the equation of the line that we're going to be using. And the point that we're going to be using is 15 and -4. So using point slope formula, we replace our y1 and x1 with our points, which is y plus 4, and our slope with -5. And that is an equation of a line that is perpendicular to this one and through that point. One more thing before I finish up is that you may see standard formula in some of your problems, and standard formula looks like this, where you have some number times x plus some number times b equal to another number. Now you're not able to look directly at this equation and find the slope like you could in slope-intercept or in point-slope. So what you have to do is use algebra to get y by itself, and you'll either have, in most cases, it will be into slope-intercept form, where you can then find the slope in there. But looking at standard form, if you see something like a 4x plus 2y equals 7, you won't be able to look at the slope and tell. You have to use algebra to solve for y. So a way we can do this is subtract 4x on both sides and divide everything by 2. So our slope then is going to be -2 of the equation, and we're just changing it from one form to another. Okay, thank you.